Hello, my dear students. Hello, my dear students. Once again, welcome back to Namma Tapasya Institute. Students, this is Mr. SUHAS Gowda, your chemistry master teacher. Student, before starting the live session, you already know, right? If you still not mark your attendance, plus mark your attendance means please like the video, share the video and subscribe the channel. If you still not subscribe the channel, please let me know. Please subscribe the channel. My dear students, before starting the live class, let me know in the chat section, how was the Josh for 2022 paper? We already done with the 2023 and 2024. How was the Josh for 2022? And also, my dear bacho, let me know in the chat section. You already clear with all the concepts. Let me know, and also please let me know my voice is clearly audible and my face is clearly visible in the chat section with some Josh. How was your Josh? Let me know, my dear bacho. Yes, I hope it's already visible and clear. My voice is clear. My dear students, today we are going to discuss your next paper. Which is your next paper? 2022. You are 2022. My dear students, look here. Let's start with the first question. Students, before starting only, I am saying you guys, I already removed the out of syllabus question because in the year 2022 and the 2023, the syllabus is little bit I already removed, guys. Okay, come on, let's discuss the first question. It is one of the easiest question. This question, as well as it is important for your physics also. It is very important for physics also, my dear students. It is important for physics also. Look here, guys. The question is, what is the question? Very simple. The question is, which of the following PV curve represent the maximum work done? Arey bhai. We need to choose the curve, or we need to choose the option which have a more work done. It will happen. My dear students, look here. First one. What is this example? This is example for cyclic process. Correct now? This is example for cyclic process. And also still look here, they are giving a isothermal process. What is the meaning of isothermal? There is no change in temperature. Delta T is equal to 0 for isothermal. Isobaric delta P, isochoric delta B, and adiabatic no exchange of heat. My dear students, look here. If you come for this example, this question, I already say you guys, this question is also important in your physics class. Here, how to calculate work done? Very simple. Whenever they give the graph, simply calculate the area under the curve. If you calculate the area under the curve, you will get the work done. Correct, my dear students? Area under the curve. If you solve all four graphs, the second graph is there now. This area is more. Correct now? This curve, especially PV curve of a second option isothermal process, have a more area. More area means more work done. More area means what, my dear students? More work done. Then the answer is option B. I hope it's clear. Option B is the correct answer for the first question. Very easy question. Let's move for the second question. It is your accession reason question, my dear students. The question is common, accession is there, reason is there. We need to check the explanation if it's correct or wrong, and we have a 4 option. We need to choose that. Let's start with the accession, my dear. So accession, ICL means interhalogen compound between the two halogens. Correct now? ICL is example for your interhalogen. Ci2 intrahalogen compound. Intra means same halogen molecule. Correct now? What they giving in the accession? ICL is more reactive than I2. Obviously correct. Interhalogen compounds generally more reactive, and also they have a strong bond compared to the intrahalogen compounds. Exception is there. FF, it is very strong bond. If you come for the reason, my dear student, ICL bond is weaker than II bond. It is true. No sir, reason is not correct. Accession is correct. That's why the answer is option C. What is the answer? Option C is the correct answer. Why, my dear student? Accession is correct, but not the reason. Interhalogen compounds, the bond is very strong compared to the intrahalogen molecule. This question exactly from your P block. Okay, P block elements. Now next move for the next question. Very easiest question from your GOC aromaticity concept. The question is, my dear students, which compound amongst the following is not an aromatic compound? What they are asking? In 4 options, we need to choose non-aromatic compound. Not an aromatic means non-aromatic compound. My dear students, look here. Which of the condition Which of the condition is important for the aromatic? If those condition is satisfied, then the molecule is called as aromatic. Which of those? First one, it must and should be cyclic. If it's cyclic, then it is, first point, it will follow. If it's not cyclic, it's a non-aromatic. Then second important, all the compound must and should be sp2 hybridized, or it is called as a planar. Sp2, it is must and should be planar molecule. sp2 or a planar. If in this 2 points, if any one point is not satisfied, those compounds are called as a non-aromatic. If these 2 points satisfied, then what we need to move? We are moving for the Huckel rule, means the compound containing 4n plus 2 pi electron in a molecule. If the n value, whenever you calculate the overall pi electrons, if n value is 0, 1 or whole number, then those compounds are the aromatic compounds. If n value it is partial, if its n value is a partial, then those are non-aromatic. Correct now? Aromatic, non-aromatic. In this condition, go with the options. Option A, all carbons, sp2. Correct? sp2. Carboanion is also sp2 hybridized. How to calculate? CH2 minus, calculate that now. CH2 minus, then you will get the answer. Carboanion, totally 6 pi electrons you have, my dear bacho. But carboanions planar, it is in the planar. It is correct. If you come for this all example, you can easily choose fourth one. Why? Here you have an alkane molecular, my dear bacho. You have an alkane. What is the hybridization of an alkane molecule? It is always sp3. Then this compound is example for non-aromatic. This is also aromatic compound. If you come for this also, this is also aromatic compound. You need to calculate the 4n plus 2. Here 6 pi is there. 6 pi, n value is 1 na. Here also 6 pi, n is equal to 1. Here in this option, n is equal to 0. Why? 2 pi electron is there. My dear students, negative charge, delocalization is happened. We are consider those also lone pair sometime. When the lone pair is involving the resonance, we are consider those lone pairs only. It is pi electrons, delocalizing pi electrons for your aromaticity concept. My dear students, this question is clear. If they ask the stability order, then you need to say that, sir, aromatic compounds are the most stable compounds, then the non-aromatic. Last we are coming with the anti-aromatic. Okay, aromatic, non-aromatic, anti-aromatic, my dear students. 2022 is there now. It is one of the easiest paper. Come on, let's move for the next question. Okay, this is from your periodic classification of elements. IUPAC name, very simple. IUPAC name, we have a column for one what you are pronouncing une, alva, une. In this one, nin. If you calculate this one, these are wrong answer. The answer is option E. Inanium, une, nn. Okay na? Nn. Now for this one, the answer is option E. Very easy. Option E is the correct answer. Shall we move for next question? Yes. This is from your chemical bonding question, my dear bacho. We already know Fussell's rule gives an idea about a covalent character. If the cation size is less, anion size is more, then more covalent character. If the same thing it will give us more ionic, then we can easily say option A is ionic. If you come for the option A only, you will most probably you get the answer. Yes, option A is the correct answer. Match the following is there now, my dear students. If you know one answer, then you will almost 90% you get the answer. Then also, if you come for the HF, electron rich. Similarly, diborane molecule, it is come for the electron deficient molecule. That's why it is also one of the reducing agent. We use the diborane molecule for the oxidizing agent, diboration. Okay, we use the same reagent in your alcohol chapter. Clear, bacho? Clear. It is easy question. Now next move for the next question. Bio, same question. It is maybe they will ask in bio also, maybe in chemistry also, because it is from your biomolecules. In both subjects you have a biomolecules. If you move for the question, my dear students, what is the question? The question is, the incorrect statement regarding enzyme is, we need to choose the incorrect statement. Okay, they are giving you 4 options. We need to choose the incorrect statement, my dear bacho. The option A, enzymes or biocatalyst. Obviously, enzymes or the biocatalyst. Correct na? Inverse of a sugar or the glucose, preparation of a glucose, and if you do the some any fermentation, you are using a enzymes as a biocatalyst. Obviously, it's correct. Again, I am saying you guys, we need to choose an incorrect statement. Second option, like chemical catalysts, enzymes reduce the activation energy of a bioprocess. Obviously, catalyst का मतलब क्या है? What is the meaning of catalyst? Either if it's a positive negative, they will increase the rate of a reaction. Means activation energy. The activation energy. What is the reactant form a product? If the reactant energy is cross the energy barrier or activation energy, then they will get a product name. What it will do? Similarly, the biocatalysts of enzymes, they are decrease the activation energy barrier. Then what it will happen? Reaction is faster. Order of a reaction is increases. Correct now? Order of a reaction is increases. Then the option B is also correct. Next one, enzymes or polysaccharides. My dear bacho, look here. The exact answer is of your option 3. Why, sir? Enzymes or the protein, not the polysaccharides. Enzymes or the protein. These are the proteins. Those are present in our body also. Enzymes. Hello, hi, Triggered Army. How are you? Okay, enzymes or the polysaccharides, my dear bacho? No, sir. Enzymes or the proteins. That's why the answer is option C. Answer is option C. Very simple. Now we are moving for your next IUPAC system from your coordination compound. This type of questions is almost common in all paper. In the case of a coordination compounds, my dear bacho, oh my god. In the case of this, my dear students, look here, everyone concentrate here. From the coordination compound, it is also one of the highest weightage nowadays. Minimum 3 questions they are asking. Please concentrate. The NEET aspirants, please concentrate coordination compound, especially the IUPAC system and the isomerism part and the theory part. Very simple chapter. I already discussed the entire chapter as a one shot in the channel also. Ella jolly. Yes, Ella jolly. Okay, already done. You can go through. My dear students, look here. The question. The IUPAC name of the complex. If you see this question, we have a homo hetero, that is completely different. This or we have another classification, depends upon the cation anion. Here we have a complex cation, complex anion. Whenever you see this type of example, you can easily say, sir, here one complex it acts as a cationic complex, one complex it acts as an anionic complex. Correct now, my dear students? Entire one complex it acts as a cationic, anionic. Here the first important thing is you need to choose which is cationic, which is anionic. My dear bacho, we already know Ag, silver na? Silver, common oxidation or stable oxidation state is +1. We already know. Why the exactly compound formation is happened? To become a stable, to form a stable thing. Here +1. If you come for this example, what they are giving in an example, look here, Ag, H2O means aqua twice. Then what is the another complex? Ag, CN, cyano molecule. My dear students, look here. Here in the case of a water, aqua, it is a neutral molecule. Neutral ligand, not a molecule, guys. Sorry. It is a ligand. Water is ligand. Then if you come for here cyano, it is also ligand. It is a negative ligand. Okay, negative charged ligand. This is neutral ligand. This is anionic ligand. Cationic, anionic, neutral na. This is anionic. This is neutral ligand. If you come for this, look here, my dear students. Silver common oxidation state is +1. If you come for this, you can know about that. The first part, it is positive charged complex. Why? Water, you need +1 oxidation state, my dear students. You need +1 oxidation state. If you give a +1 here, -1 here, +1 here, -1 here, by using a options only you can easily arrange. By using a what looking, sir? What looking, ma? Angel Priya Gowda, tell me, ma. Look here, guys. if you come for this example, they are giving either +1, either +2. +1 is a common oxidation state or the stable oxidation state. +1 you require. Water, neutral ligand, 0. This oxidation state, it is equal to the charge. Correct now? This oxidation state, it is equal to -2. You need to transfer -2. That's why I am arranging as a +1, -1. By using this arrangement, my dear students, the first part of the sphere or the first part of the complex, the 50% of the complex, it is cationic. Then the remaining 50%, it is anionic. Then our 50% job is done. Then by using this common oxidation state only, you can remove the +1, +2. Common oxidation state not stable. Okay, remove those options. If you come for the third and fourth option, my dear bacho, look here. Here, very simple. Here dicyanide is there. We already know what is the order. How to write the IUPAC system? First you need to start with a cationic complex. Now cationic, then anionic. Cationic is first. Then you need to use aqueous. That's why answer is 4. Very clear, very simple. Option is 4. Here the first important thing, you need to identify which is cationic, which is anionic. Then your job is done. Now, next move for the next question. Gadolinium as a low value of third ionization enthalpy. Gadolinium is the lanthanoid series. Lanthanoid series element, you can easily know about this one because it contains a D block elements. In the F block elements, we know D, 5D 0 to 1 we are writing now. It will contain a D block element. Why it have a low third ionization enthalpy? Because due to the I exchange enthalpy. It is very common, very simple. Everyone is know about the lanthanoid actinoid series. The answer is option B. Okay, option B. Next move for the chemical bonding question. See here guys, the difficulty level. You need to just analyze the question, then you will get the answer. That's why go with the chemistry. You can easily score 180 out of 180. Oh, you need to join for Tapasya crash course. For a more about if you want to learn from your SUHAS, then very simple. In the video, you are getting a one number. Simply call that number or download the Tapasya Live App. You can know about entire thing about the institute. Now the question is, my dear students, next question. Among the following, which one have a maximum lone pair electron repulsion? Maximum electron means what? Electron, same charges always repel to each other. Opposite charges attract now. More electron pair, more repulsion. The answer is very simple, XeF2. Why? Here, if you consider all the S, oxygen family, one pair is there, remove that one. Here also, halogen, 5 electron already busy with the fluorine bond, remaining one ho gaya. Here if you come for the Cl, 2 pair, but here you have a 3 pair because xenon, it is your noble electron. Still we have an exception. Most of the time I say you guys, exception. I am not liking exception, but being a chemistry teacher, I am only the exception. Correct now, I am only the exception. Because exception, if you know about the exception, then your answer, or then you can easily answer all the thing in chemistry. The answer is XeF2. We don't want to discuss more about that one. Easy question. Next question, my dear students. Which of the following statement is not correct about diborane molecule? Actually, this is also out of syllabus question, but you can easily give the answer. That's why. B, diborane, B2H6 na. It is best example for banana bond or bridged bond, we call it as a. Here, look here, my dear students. This is the structure of the B2H6. Okay, it is one of the oxidizing agent, my dear bacho. Look here. There are 2 3 centers and 2 electron bond. Correct now? 3 centers and 2 electron bond. Yes, it is correct. Second one, if you come for the 4 terminal BH bonds or 2 center 2 electron bonds. Yes. 4 terminal hydrogen bond we have. Third point, the 4 terminal hydrogen atoms and the 2 boron atoms lies on the one plane. Yes, obviously same plane. It is also correct. If we come for the last option, boron atoms or sp2 hybridized. No. How to calculate the hybridization? Very simple. Calculate here. Boron. Here we have it 2 extra. 2 plus 2 means 2 plus, if you calculate that for now 4 atoms. 4 means sp3. The answer is option D. Option D is a wrong answer. Why? Because borane molecule, diborane molecule, both boron atoms have sp3 hybridization. Okay, my dear bacho, next move for the next question. It is statement question from your organic. The question is, why it is smooth? Yeah? Why it is smooth? 1 second, guys. Yes. Look here the question. Statement 1 they are mentioning the boiling points of aldehyde and ketones are higher than hydrocarbons of a comparable molecular masses because of a weak molecular association in aldehyde and ketone due to dipole-dipole interaction. Obviously, compared to the comparable hydrocarbon masses, aldehyde and ketone have a more boiling point because dipole-dipole interaction. As statement 1 is correct, then you can easily remove the option B and also option D. Either option A, either option C is the answer. Now next move for the statement 2. The boiling point of aldehydes and ketones are lower than the alcohols of similar molecular masses due to the absence of hydrogen bonding. Correct na? Obviously correct, sir. First carboxylic acid, next alcohol, next aldehyde ketone. Why? Because due to the hydrogen bonding, inter or intra hydrogen bonding. Due to that one, my dear students, statement 2 is also correct. Statement 1 is also correct. The answer is option A. Aldehyde and ketone are lower than the alcohol. Correct na? Boiling point are lower than the alcohol. Lower, obviously lower than the alcohol. Next question, guys. Given they are mentioning it 2 statements. The boiling point of the following hydrates of group 16. Come here, group 16. Group 16 is your chalcogens. Why we call it as chalcogens? Because we are obtaining the entire group 16 elements as a word form. Correct? That's why we call it as chalcogens. If we come for the statement 1 and statement 2, statement 1, my dear students, the boiling point of the following. Obviously it is wrong. Why? We have an exception, guys. First we come with a water, then cesium, then tellurium, last we come with a H2S. Why? Because due to the extending hydrogen bonding, it is extending, that's why. According to this, my dear students, statement 2, what is the statement 2? The boiling point of these hydrates increase with increasing molecular mass. No, my dear students. Both statements are incorrect because 16th group we have an exception. Why? Hydrogen bonding. For example, new bond is formed. We require the extra energy to break that bond. That bond is also involved in the compound. That's why we require the extra energy to break that bond. That is the thing. That's why the answer is option C. Option C. Now, my dear students, graphical representation in the case of a chemical kinetics. Whenever I taught you guys, I already explained that thing because what I say is, guys, graphs are important. Focus on graph. If you focus on a graph, now you will get a good marks. My dear students, look here. The given graph of a representation of a kinetics of a reaction. This is the graph which will represent the kinetics of a reaction, chemical kinetics. Okay, in the case of a chemical kinetics, we already know chemical kinetics, it deals with a rate, how speedily it will occur. We have a order means stoichiometry. We have a rate law. Rate is directly proportional to the concentration power of their stoichiometry on the experimentally determined. We have a powers, add the powers, then you will get the order. On the case of a order, we already know. Here, look here, we have a y index with a constant temperature. Obviously, constant temperature they are mentioning. Here, the main important thing is we are getting a straight line. We are getting this straight line in a 2 case. In 0 order as well as first order we are getting. My dear student, 0 order we already know. Whenever you write the 0 order reaction, how we will writing a 0 order reaction? 0 order reaction R, it is directly proportional to the A power 0 order. It is always 0. R is equal to K. It is never depend upon the initial concentration, 0 order reaction. Then what is the integrated rate equation? A minus A naught. That is equal to KT. We will get the integrated rate equation to calculate the rate constant value. Here, my dear students, here we already know it is never depends. If you, here look here, 0 order, they are mentioning always 0 order. In the case of a 0 order, but we need to choose what is X, what is Y. Here, rate is depends upon the concentration. Any depend upon the concentration in the case of a 0 order. Here concentration value is same, then we can easily choose Y is rate and X is concentration in the case of this one. Okay, Y is rate, X is concentration, then you can easily remove the option A and option B. Either option C or option D is the correct answer. Look here, and also we have another important relation of a T off for the first order reaction, 0.693 by K. T off also same one. Here we have a T off in the case of this one. Here, then here you have a concentration. Then this is also the correct answer. The answer is option C. Why, my dear students? We already know whenever you plot a graph against rate and concentration, concentration is same. It is not depend. It is not the rate of a reaction, it is not depend upon the concentration. Rate and concentration, if you come for the TF value, again TF of the first order reaction, it is not depend upon the equal. For the TF, what is the relation for the zero order reaction TF? You will get as a A0 by 2K. Correct na? 2K. A0 by 2K. It is for TF. Correct? Next also from your organic, my dear bacho, organic question. The question is the incorrect statement regarding chirality. Chirality means the compound containing 4 different attached with 4 different groups. It will have a optical center, and we already discussed about that one also. Here SN1 reaction is 1:1 mixture. Obviously both enantiomers. Why? Because in the case of a SN1, my dear students, we have a carbocation like this. Carbocation sp3 hybridized planar na sp2. Sorry, sp2. It look like this one. sp3 we were coming sp3 only na. 3 years sp2 we are coming carbocation actually. If we come for this one, my dear students, look here. What it will happen? It is planar. Maybe nucleophile attacking upward or the downwards. Anywhere it can attack from upward or the downward, because it will get a both enantiomers form. It is correct. Second one, the product obtained by the SN2 reaction of alloalkene having chirality at the reactive site. So inversion of configuration, obviously SN2, what it will happen? In single step it will happen. We require the strong nucleophile now. What it will happen here? When nucleophile attack is happened, here the leaving group, it can easily remove. What transition stage we will get? We will get the reaction answer. Option B is also correct answer. Then the C is enantiomers are superimposable mirror images of each other. That is true. No sir. Enantiomers are the non-superimposable on its mirror image. That's why the option C is the answer. It is an incorrect statement. Enantiomers is nothing but what? They are the mirror image but non-superimposable. Look here guys. Superimposable is nothing but like this. But in the case of enantiomer, what it will happen? Like this. Reverse, exactly opposite. That's why we call it as a non-superimposable. That's why the answer is option C. Next question, very simple. Next is also from your organic. In 2022, compared to inorganic and physical, organic questions little bit more. Okay. Now the question is, which of the following sequence of a reaction is used to synthesize chlorobenzene? Suitable. Everywhere we will get, but the suitable one, we already discussed the same question. What is the answer? Option A, benzene. Chlorine in the presence of anhydrous FeCl3. It is also called a Friedel-Crafts reaction. You will get the answer. Very simple question. Next question, my dear students. Identify the incorrect statement from the following. All the 5 id orbitals are different in size with compared to the respective 4d orbitals. True, na? Why? Because size of the orbit depends upon the n value. According to your principal quantum number gives the idea about your size of the orbit. Then obviously it is correct. Second one, all the 5 4d orbitals have a shape similar to the respective 3d. Obviously shape is same. Then the third point, in an atom all the 5 3d orbitals are equal energy in free state. Obviously same concept from your CFST we discussed that one. All with the before attach the ligands, all are in symmetry. Whenever it attach, it is in free state, have a same energy. Then whenever the ligand is attached or the ligand is attached, what it will happen? The symmetry is fails. Then it will move its energy levels to the next level. That is the thing. That's why it is also correct. Then the remaining we have a last option. This is wrong actually. The answer is what? The shape of a dx5 orbitals are similar to each other and dx5 dz's are similar. No, these 3 are similar, but in the case of these 2 it is dissimilar. These 2 dissimilar. Okay, that is the thing, my dear bacho. Very simple. Next question. It is from your qualitative analysis of your GOC. Jaldas method, we already know Jaldas method, it is analyzed as ammonia. You can easily choose option C is the correct answer, because derivative of ammonia we are identify, or we are what it will do, we are analyze or we are estimated. That's why the answer is option C. Without discuss the answer, you can easily answer the option C is the correct answer. Next question, it is from your P block again. The question is, my dear bacho, choose the correct statement. Diamond and graphite have a 2-dimensional network. No, graphite has a 2-dimensional network, hexagonal arrays, not the diamond. Second one, diamond is covalent and graphite is ionic. Reverse, both are covalent only, bhaiya. No, this one. Then the third one, diamond is sp3 hybridized and graphite is sp2 hybridized. Obviously it is correct, sp3 hybridized, that's why there is no electron remaining in the compound, that's why it is a what? It is a non-conductor. It is a non-conductor of electricity, but in the case of a graphite we have a hexagonal array like this, smooth, that's why it is a conductor. Okay, if you come for the next option, both diamond 4, how can it is plus 4? How can it is plus 4? 1 second. S. How can it is plus 4? That's why the answer is option B. Okay, let's choose why this or wrong answer. Let's discuss about that one. If you come for the first one, my dear students, here also we need to choose, I think, incorrect only. Yes. First one, alkali metals react with the water to form their hydroxide. Obviously, +1 they can form. Ionization enthalpy of alkali metal decreases from top to bottom. What is the meaning of ionization enthalpy? The energy required to remove the outermost electron from its outermost valence shell. Obviously it is correct. Lithium is the strongest reducing agent among the alkali metals. Obviously reducing character decreases from top to bottom. The answer is option 2, because KO2, it is called as a super oxide. Why? Positive. K, it is max to max +1 only. Potassium +1. Alkali metals is common oxidation state, they have a +1. Okay, they have a +1. Here oxygen have a minus of oxidation state in this compound, it is called as a super oxides. What we call as a super oxide. That's why the answer is option B is a correct answer. Okay, option B. Now move for the next question. This question is from your solution chapter, my dear students. The question is, which one is not correct mathematical equation for the Dalton's law of partial pressure? Actually, this is from your gaseous chapter, gaseous state, but in the case of a Raoult's law, whenever we derive the expression, we are using this one. The answer is very easy, xi into pi naught. Initial pressure is directly proportional to the mole fraction and their vapor state, pure pressure at the vapor pressure at their pure state. You can easily answer option D. Next, move for the next question, my dear students. They are giving it two statements here. We need to identify which is the correct statement. Statement wise question. The statement 1 is the acidic strength of a mono-substituted nitrophenol is higher than the phenol because of the electron withdrawing group. Very simple. If you want to discuss the acidic character, what happened for this one? 1 second. Yes. What happened? Yes, it's coming. Sorry guys. Look here everyone. If you come for this one, now we already know acidic character is nothing but more withdrawing group. More withdrawing group is nothing but minus I effect. More minus I effect, more acidic character. Obviously nitro is one of the most strongest withdrawing group. Obviously compared to the phenol, nitrophenol have a more acidic character. Statement 1 is correct. Then you can easily remove option 4, I think. Yes, option 4 and option 2. Remove. Elimination method, best method. Then we remain with option A and option C. Now the next one, statement 2. Orthonitro, metanitro, para will have the same acidic strength. This is the wrong answer. What is the actually acidic strength? First one you come with a para due to symmetry one, due to opposite it can easily withdraw more. Then the next one with your meta, then one with the ortho. Ortho, why ortho is have a least acidic character? Because due to interhydrogen bonding. The interhydrogen bonding is asked in the next year. Look here, the connectivity, look here in the organic. What they are asking? They are asking connective parts. That's why PYQs are important. If you know which is more, which have a reason, then you can easily identify which is interhydrogen bonding in the next question or next year paper. Okay, this is the thing why we required more PYQ sessions. That's why our Tapasya come with this idea. You need to subscribe the channel, my dear students. That is very important. Next the question is at 219 the standard they are giving the few standard hydrogen electrode potential. For this you must and should be know about that, my dear students. For a standard electrode potential, S4P value is always equal to minus SRP or reverse, or SRP is equal to minus S4P. You must and should be know about reducing potential. Oxidizing, reducing potential, very. Oxidation, increasing, this is reducing potential. Okay, E naught, oxidizing, cathode, anode, that is important, you must and should be know. By using that one, and also another important point, we also know for a spontaneous, E naught should be positive. E cell, sorry, not E naught, E cell. What is E cell? E cell is equal to E cathode minus E anode. What happens in the cathode and anode? Cathode, reduction, anode, oxidation. It is common. Oxidation, anode, what it will happen? Oxidation means oxidizing number is increases. Cathode means cathode, it is reduction means oxidizing number is decreases. If you calculate that, you can easily identify the option 4, it is a wrong answer. Option 4 is the wrong answer. In all these three cases, you will get a E cell value is a positive, but option 4 it is not getting the answer. Very simple answer. Very simple question. Next, move for the again the same thing, my dear bacho. Again the same thing, my dear bacho. We are going with the next statement wise question. Statement wise, more statement wise questions they are asking in the 2022. Statement 1 is, in the coevolution of a negative solution, the flocculating power of the three given ions in the order. Actually, this is from also out of syllabus question, surface chemistry, but easy. We already know if the charge increases, then what it will happen? The power, flocculating power is more. That's why option 1 is correct. Statement 1 is correct. But in the case of a statement 2, what they are giving? In the coagulation of a positive solution, the flocculating power of the three given salts in the order, no. It is exactly reverse, because charge, they are here only mentioning about the charge. More charge, more flocculating power. If you calculate this, Na plus 1 is coming. Here it is plus 2 plus 3 is coming. Plus 1 plus 2 plus 3. That is reverse now. Very simple question, basic question. Statement 1 is correct, statement 2 is incorrect. That's why the answer is option C. Very simple. Option C. Next, my dear bacho, next question. Primary aliphatic amines react with the HNO2 to give unstable diazonium salts. Very important. The preparation of BDC, yes, obviously it will give. What is in the case of a statement 2? Primary aromatic amines react with HN to form a diazonium salt. Yes, they are giving only. Which are stable even above 300 Kelvin in the light of the above statement. This is actually wrong, my dear students. Look here, my dear students, whenever you write a BDC, now what you were mentioning are NH2, whenever it is react in the presence of sodium nitrate plus HCl, or you can combinely call as a HNO2. We are preparing on the time. Why? Whenever I explain the BDC, we are preparing a BDC at a particular time. Why? Before. And also we maintain the temperature from 0 to 5 degree, means 273 to 278, because it is very unstable. If we increase the temperature, then it is directly form a phenol molecule. Directly form a phenol molecule. Correct? Directly form a phenol molecule. It is unstable. Before only we need to, it is stable at 278, below 278. That's why whenever we want to prepare a BDC, we always prepare the BDC at the same time. At the same time, we are going to prepare the BDC. That's why the answer is option C. Option C is the answer from the your amine concepts. Okay, next question from your very basic concept from the solution. Also, this question maybe they will contain, because the concentration terms we are going to discuss in solution also in your first chapter, some basic concepts. Here are the main things, students. 1 molar solution that contains 0.5 mole of a solute there is. We already know what is molar, not a molar. Molar means molality. What is the major difference between molarity, molality? Both are concentration terms only. Mole per liter, mole per kg. Then we are going to calculate in the gram, not in ml. Then option A and C are wrong. What is molality? Number of moles in given kg of a solution. Here, look here, my dear students. Molality, how many moles they given? 1. Number of moles divided by weight, some weight. Okay, it must and should be in kg. Then divide 1 by 0. No, not that. W 0.5 divided by 1 is nothing but 0.5. 0.5 kg. My dear, which is 0.5 kg means and 500 gram of a solvent. Very simple. What is molality? Number of moles in kg of a solvent. Solvent means solute, solvent, mixture of solution. Solute means lesser amount, solvent means more amount. Correct? Now solute means the compound or the components having lesser number. Solvent means more number. That's why the answer is option B. Answer is option B, my dear students. Clear? Now let's move for the next question. It is from your from your carboxylic acid topic. Very simple. They are mentioning here, I will write here because it is little bit not visible for you guys. I am writing here RMGX, Grignard reagent na, Grignard reagent. This is react with a CO2, planar molecule, plain structure of the CO2, C double bond O. Then here we are getting one intermediate Y. Further on hydrolysis they are doing. Further on here they are mentioning in the presence of dry ether. Obviously they need to mention Grignard reagent is there. Further on they are getting RCOOH whenever they do hydrolysis. Okay, whenever they do hydrolysis they are getting carboxylic acid. Here the question is, what is Y in the above reaction? This is the main thing. Why you must and should be know about the mechanism. You know the answer, but the mechanism is very important, my dear students. Look here, my dear students. Here what it will happen, RMGX, we already know metal is always carries positive charge, then R minus it is forming. Here this compound, we have a electronegative atom with this one, then it will carry partial positive charge. R minus it will attack here. Then what it will happen, carbon valency. What is the valency of carbon? It is 4. Then one bond is moving here, this carries a O minus, then this bond is attacked here. Then what it will form, what is the intermediate? We can easily say C double bond O. Here you have a R, here you have a O minus, then you need to combine the positive part with the negative, opposite charges, my dear bacho, opposite charges. O minus MgX. Here where this intermediate is there, further on hydrolysis, what it will happen, MgXOH twice. What it will happen with this MgOH twice into halogen it will forming. Correct now? Then what is the answer, my dear bacho? The answer, where is that one answer? Where is that one? RCO minus MgX plus R3CO minus. No, it is not wrong. It is also wrong. It is also RCO they are giving. The answer is this one. Option A. Option A is the answer. Correct na? Option A is the answer. Very simple. Next question, my dear bacho. Next move for the next one. The next one is from your stoichiometry chapter. Mole concept. The question is, what mass of a 95% pure Kako3 calcium carbonate? Same question is there in your next PYQ also. Kako3. They asked more question from Kako3 because Kako3 is the love from the chemistry. One of the famous Kako3 calcium carbonate. What is the compound name? Calcium carbonate. What is the, before we can, if we identify the Kako3, we can easily say, sir, that molecular mass is 100. Molecular mass, molecular weight is 100 for the Kako3. Being neutralized 50 ml of 0.5. How much they are giving? 50 ml of 0.5 molar HCl. Solution according to the following reaction. My dear students, what is the N value? How many electrons are involving? 2 electrons na? N value Kako3. Here N value, neta value is N factor value 1. Here look here. 1 mole of Kako3 requires 2 mole of HCl. Then here they are giving 50 ml of 0.5 molar HCl. Calculate the Kako3. Very simple. Look here. N1V1 is equal to N2V2 now for neutralization. By using molarity they are giving. Molarity, convert for the molarity, my dear students. Molarity M1, N1, V1 is equal to M2, N2, V2. Clear? Here, my dear students, volume they are giving in a gram. You can calculate by using a molarity. Gram you can calculate by using a gram only. Here, come here. Here 0.5. N value is 1. Volume. Let's calculate in the liter and the gram. 50 divided by 1000. 50 by 1000 clear. Then similarly M2. N2 value कितने हैं calcium carbonate के लिए 2. Molarity M2 mass we need to calculate. You can go with a mass only directly. M2 value 95% na, 95 by 100 into M by 95. You will get this one, volume and the molarity. Okay, number of moles na, number of moles divided by 100, M by 100, sorry 100, 90% na, 90%, 95%. Calculate the M value, you will get 1.32 gram approximately. You will get 1.32 gram, very simple. Calculation is important, very simple. Clear? Next question. From your ionic equilibrium. The question is very simple, my dear student. By using a question only you can identify. pH, we need to calculate the pH of the solution containing 50 ml of each 0.1 mole of sodium acetate. CH3COONE, sodium acetate. It is the salt of a strong base and the weak acid. Okay, and also 0.01 molar acetic acid. 0.01 molar acetic acid. My dear students, look here, everyone. Acetic acid, it is the weak acid. What are buffer? Buffer is the mixture of the solutions which are not altered. If you would say where is the entire thing if it's not altered its concentration. If you come for this, my dear students, acetic acid with a sodium acetate, acetic acid with a sodium acetate, it is the best example for the acidic buffer. Two type of buffer we have, acidic and basic buffer. What are acidic buffer? What is the meaning of acidic? Weak acid with a strong basic salt. Basic buffer, weak base with a strong acidic salt. Here in this example, my dear students, it is best example, and also they are giving pKa, then you can easily identify it is a weak acidic buffer. How to calculate pH for the weak acidic buffer? pH is equal to pKa plus log of salt by acid, log of salt by acid, log of salt by acid. If you come for the pKa value 4.57, here what is the salt concentration? Here both our volume is there, we can calculate the volume 50 ml 50 ml, cancel that one. Log of, you come with that one, salt 0.1 divided by 0.01, 0.1 divided by 0.01, it is nothing but 10 power 1, correct na? 10 power 1. Log 10 value, how much log 10 value? 1 sir, 4.57 plus 1, you will get the 5.57 as a pH. What is the buffer pH of this question? The pH of this buffer is means 0.1 sodium acetate, molar sodium acetate, 0.01 acetic acid is 1. Okay, sorry, not 1, 5.57. Very easiest one. Next question, my dear students. The next question is match the list question. They are giving the, actually this is also from your organic. Here, look here guys, the question, cyanoate in acetal skiff base oxime is there, the reaction of carbonyl compound, which is from which that one? We already know carbonyl. If you want explanation, I can give you within a 5 minutes explanation. Look here, this is the carbonyl compound. Okay, aldehyde, if you take the aldehyde, the carbon, it is always ready to accept the nucleophilic addition. Q by, why? Because carbon here withdrawing group is there, that's why it is from a partial positive charge, this is partial negative charge, electronegativity varies. Due to this case, nucleophile, it is always attacked where the electron density is low, opposite charges. Here if you consider the HCN, H plus Cn minus, what it will happen? Attacked here, it will form cyanoid ring, CNOH it will forming. A, for a A4, then after that oxime, obviously NH2OH, then skiff base, RNH2, acetal, alcohol, acetal, Me-acetal we are coming, what? OCH3 it will attacking, R, C, OH, O, R it will coming with the H. Again in the next case, this is replaced by another R, it is acetal, it is acetal, it is acetal, this is the thing, this is acetal. The answer is for A4, option D, only A contains 4 only. By using, see here guys, in the case of a match the following, by knowing only one option answer, you can easily get the answer, but sometimes it will maybe varies, you need to get 2. If you know 2, it is very easy. I hope for bio it is very important. Why? In the case of biology, more match the following questions coming, I think. Correct? Next question, my dear students, you can easily say the answer. Which is the limitation of MOT? O2 plus ion is a MOT not VBT. O2 plus ion is a diamagnetic. Actually, it is a paramagnetic. Correct now by using MOT. That's why the answer is option D is the incorrect statement. You can, without knowing also, you can easily say. My dear students, look here, concentrate here. What is the first option? The bond order of O2 plus, this one is 1. For this, I already give you the one of the best bond order. How to calculate bond order? Bond order you need to calculate by NB, total number of electron present in bonding orbital, and the total number of electron present in anti-bonding overall divided by 2. This is the actual bond order calculation method, NB minus NA divided by 2. My dear students, look here. Here they give the bond order respectively, very simple. Instead of calculate by using this, we have a one trick now, 14, 13, 12, 15. You write the values from few values. Here O2 O2 plus, O2 means 16 now, plus means this is 16 electron, 15, this is totally containing 17, this is containing 18. Okay, up to 18 you need to write. Okay, very simple. 14, nitrogen, N2 molecule, total how many electrons we have? 14 now. Bond order is what? 3. Then for reverse one, 2.5, remove with a 2.5. Then for another one, 2, this is 2. Then this one it become 1.5, this is 1. By using this, 15 electron is there, 2.5, it is correct. 16 electron is there, 2, it is correct. O2 2 minus 1.5 and 1, that is option A is correct. Option A is correct. If you come for the option B, C2 molecule as S, we have a 2 general, it is correct. H2 plus ion has a 1 electron, obviously H2 plus. Totally 1 hydrogen, 1 electron is there. 2 hydrogen means 2 molecule, H2 molecule, 2 hydrogen is there. Correct now? Helium, the corresponding noble gas configuration. In helium, 2 is there. Remove the 1 electron, then obviously 1 electron. O2 plus is ion is a diamagnetic. Actually, we already know what is the electron configuration, how to we are filling according to MOT. We already know, right? Two methods. If the electrons contain is more than 14, less than 14, more than 14, it is sigma 1s, sigma 2s, sorry, sigma 1s star, sigma 2s, sigma 2s star. Then what we will get? Sigma 2pz. Okay, more than 14 are 2pz. Then after that, pi 2px. That is equal to pi 2py. Then pi star 2px. That is equal to pi star 2py. Then after that you come with a sigma 2pz. You come with a sigma 2pz. Sorry, sigma star. Here if you come with this one now, here totally 16. 2, 4, 6, 8, 10, 1, 1. No, 10, 12, 14. Here 1, 1. 16. Here look here. Paramagnetic, diamagnetic. Paramagnetic matlab kya hai? What is the meaning of paramagnetic? If it contains lone pair electrons or single unpaired electron, it is para. If it contains a paired electron, it is dia. Then according to this, here look here my dear students, we have unpaired electrons. In the case of anti-bonding, then according to that O2 plus now we need to remove one also. Okay, remove the one. Yes, unpaired electron, sorry, O2 plus. It is para. Obviously para, correct? It is obviously para. This is the thing. Next question, my dear bacho. Again, it is statement wise question. First statement is in Lucas state primary, secondary, tertiary or distinguishing on the basis of their reactivity with concentrated HCl and anhydrous ZnCl known as Lucas reagent. Obviously, Lucas reagent, it is the reagent used to differentiate primary, secondary, tertiary alcohol. Okay, second statement, primary alcohols are most reactive students. This question is ditto, same repeated in your next PYQ 2023, same. We already done with 2023, now same question is there. According to this, my dear bacho, we already know anhydrous zinc chloride plus concentrated HCl Lucas reagent. Whenever you have a primary alcohol, reactivity is very less. Second, tertiary. If tertiary, immediate turbidity it will happen. If you have a tertiary alcohol, immediate turbidity it will happen. Secondary alcohol after 5 minutes. Primary, no, we need to heat that one. Then after some time it will happen. The answer is option statement 1 is correct, statement 2 is incorrect. Option 3. See here, most of the questions containing option 3 is the answer in the statement wise. Next question, my dear students, the next question is, if the radius of a second orbit He plus ion is this one, what they are giving? Here they are mentioning the He plus, radius of the He plus. How much it is for? 105.8 pm. What is the radius of the third Bohr orbit of Li plus 2? We need to calculate Li plus 2. Here n value, second, n is equal to 2, here n is equal to 3. We already know radius, it is directly proportional to the z square not n square by z. In the case of energy, z square by n square. Energy frequency, it is reversed. In a radius, it is n square by z. And also you must and should be know about the relation of total energy, kinetic energy, potential energy. Kinetic energy, total energy is equal to minus of Ke, that is equal to half of Pe. Potential energy, that is the important thing. Here in this case, my dear students, radius is directly proportional to the n square by z. Here, look here, radius of Li plus 2, radius of helium plus, it is equal to n square now. N square means here what is the n value for the lithium? 3. it is 3 square divided by Z is there, Z value, what is the atomic number of lithium? 3. Then it will become reverse, correct now? Here Z is coming, here what is the Z value of helium? 2. Then divided by order is 2 square na, 2 square. Here calculate, 1 2 1 2 cancel, 1 3 1 3 cancel, it is 3 by 2. Here radius of Li plus 2 we required, helium, multiply with this helium, what is that one? 105.8. okay, 105.8. calculate this one, how much we will get? Let me know in the answer. Let me know in the answer how much we will get. We will get a 158.7 pm. Okay, pm we will get. Okay, what is the A naught value, my dear students? 0.589 pm, correct now? First orbit 0.589. that one is very important, it is easy. Next, move for the next question, my dear students. It is from your physical chemistry. Look here the question, look here the question, my dear bachon. For a first order reaction, A is P. Okay, they are giving A is equal to P in the first order. Initial concentration, they are giving a naught value, initial concentration, it is 0.1 molar, which becomes means final concentration after some time. T value they are mentioning 5 minutes, T is equal to 5 minutes. We already know what is the SI unit for here, what we need to rate constant, my dear bacho. Here A, T at whenever T is equal to 5, AT value they are giving, what is the AT value? 0.001 molar they are giving. Then you need to calculate the reaction in per minute, they are mentioning already per minute. How to calculate rate constant? R is equal to 2.303, what? T divide into log of A naught divided by A. Correct now, this is the thing. Here you will get 2.303 divided by T, 2.303 divided by 5 minute log of, okay, divided by 5 minute log of A naught concentration, how much? Log of 0.1 divided by 0.001 na, means 10 power 3, means 3 log alva, correct na? 2.303 divided by 5 into 3. What is the answer? How much we will get? Let me know in the chat section. How much we will get? How much we will get? Okay, 0.1 divided by 2 na, 10 power 2. 10 power 2. How much we will get? We will get approximately, the answer is 0.9. 0.9 per minute. The answer is option A. Sorry, option B. The answer is option B, 0.92. Very easiest one. K is equal to 2.303 divided by T into log of initial by final. You will get the answer. Clear that one first. Next question, my dear students, again the very easiest question, your IUPAC name of the following molecule. Here IUPAC name we already know. First we need to give the first preference for the functional group, then you can easily remove these two options. The numbering is starting from here 1 2 3 4. No sir, it is not happened, sorry, it is not the correct manner. We need to give the first order, first priority now. 1 2 3. Here for 1 bromo is there, 4 5 6. Hexanol is there, everywhere hexanol is there, yes. Here 4 methyl, hexane 3 ol, it is correct. Here if you come for this one, 1 bromo 5 chloro, the option A is correct, very easiest one. 1 bromo 5 chloro, 4 methyl hexane 3 ol. Okay, hexane 3 ol. Here my dear students, very important thing is we need to give a first priority for the functional group, then after that alphabetic order, you manage the alphabetic. A B C D R B C M, it is V C B C M, we will get the answer. Now the next question, the pollution due to oxides of sulfur gets enhanced in the presence of, okay, pollution due to oxides, which of that one? Particular matter, yes, obviously correct. Ozone, obviously, yeah. Hydrogen peroxide, yes, obviously. Hydrocarbons, no. That is not the correct answer. By using that, it is normal EVS question, my dear boys. So the answer is option B. Option B is the answer. Next question, my dear students, look here. Find the EMF of the cell in which of the following reaction takes place at 298 Kelvin. Very simple. How to calculate E naught cell? I am always telling you guys, don't consider cathode by R0. It is very confusing. Instead of considering QC, okay, here what is the formula? Formula is equal to E is equal to E naught cell 0.059 divided by N. N means number of how many electrons are involved. It's exchanged in the redox reaction, because electrochemistry or the chemical reaction for the electrochemistry, it is always follows a redox reaction, correct? No, that's fine. Into log of QC. Log of QC means product by reactant. Here product, we have a Na plus 2, Na plus 2, Na plus 2 divided by Ag plus. Here 2 molecule of Ag plus is there, concentration power we will get. Then if you come for this E naught cell, what is the E naught cell value? They are already given 10.5. Here how many electrons are involving? Here Na to Na plus 2, 2 electrons, 2 Ag, 2 electrons. So into stoichiometry, 2 electrons are involving. 0.059 n value, what is the n value here? 2. Then log of Na plus 2 concentration is, they are giving 0.001. This is also 0.001. Both are cancelled, your value is 1. If you calculate this one, what you will get? What is the exact answer? How much you will get? Let me know. You will get 10.415, my dear students. 10.415. 10.415 you will getting. Oh my dear guys, look here. It is not 1. We need to square this one. 0.0001 square. Then what it will happen? You will get a 3. Log 10 power 3 you are getting. Log 10 power 3 means log 3. Log 3. This one 0.059 divided by 2 is nothing but 0.259 into 3. Then what is the answer? You will get the answer as a 1.03, right? 1.05 volt you are getting. Option D is the correct answer. Option D is the correct answer. Next question, my dear students. I think we are almost at the end. Okay. We have 5 questions left. Next question. Yes, this is now one of the easiest question. It is also from your amine compound. Look here, guys. First we have a cyano molecule. We are doing reduction by using a strong reducing agent. What it will happen? It will converted as ethanamine, CH to NH2, amine. It will converted as an amine, my dear bachcho. First step is done. Next one, NaNO2 plus HCl. In this paper only we discuss primary alcohol, whenever it will undergo oxidation in the presence of HNO2 or the mixture of NaNO2 and HCl, it will produces alcohol, not alcohol, BDC. After BDC we will get a alcohol whenever at some condition above 0 to 5 degree. If you increase that one, you will get that one. Then the answer is benzene, BDC it will getting. What we will get in BDC? BDC, N2 plus Cl minus, clear? Further on hydrolysis, we will get option 4, very easy. We will get a alcohol molecule, very simple. Next question, my dear students, next question, look here. The order of energy absorbed, very simple, I already explained this one. If the compound is more stable, then the energy absorbed is also more. In the case of this, we already know, compared to the aliphatic, aromatic compounds are more stable. Why? Because those contains a cycle structure. Here also En, chelating ligands. Look here, more chelating, more stable. C is the most stable now. C is the most stable, then it will have a capacity to absorb the energy more. Then C is the first. Then after that, here compared to here only one En molecule, here En2 is there. Then A is more stable. Then the answer is option C, CAB. Very simple, CAB. If you come for this, you can easily say that answer is amidite ore is Fe2O3, A is equal to 3, correct? Magnetite ore, it is calamine, and the calonite is there. Calonite is D is equal to what? 4, means calonite is this one, aluminium ore. Then the amidite is Fe2O3. Then the calamite, it is magnetite, it is calamine is ZnCO3S. C is equal to 2, where is C is equal to 2, B is equal to 1. Hematite, no, one second. Hematite, A is equal to 3, A is equal to 3, we are getting here. Yes, the answer is option B. Answer is option B, very simple, option B is the answer. Okay, next question, it is direct question. The question is, in the neutral or faintly alkaline medium, KMnO4 oxidized to iodate. We already know, students, KMnO4, it will changes its oxidation state. Its oxidation state is +7, correct? Its oxidation state is +7. If it's in a neutral, it is changes to +4, means 3 electrons. If it's in a strong acidic medium, +2 means 5 electrons. Alkaline medium means strong basic medium. Only one electron, 7 to 6. The answer is option A. Option A is the answer, +7 to +4 in a neutral medium. Next question, my dear students. Okay, ozonolysis concept. Look here, everyone. The question is, compound Exxon reaction with a O3 followed by zinc H2O gives formaldehyde and the 2-methyl propanol. Let's write down the first structure. Both are aldehyde only. Here, first one formaldehyde HCOH. Clear? HCOH we are getting. Then 2-methyl propanol as a product. 2-methyl propanol. Propanol means 3 carbon. This is the structures. These are the structures. I already explained you guys. Means we simply cut the molecule at the O. CO is there here. Look here. Means we must and should be get double bond at the end. Then these two are the wrong answer. Here, what is the structure of option A? 3-methyl but 1,2-Ne, 2-methyl but 1,1-Ne. 4 carbon. This is one. Then both cases you are getting a formaldehyde. Simply cut. You are getting a formaldehyde here. Here getting a formaldehyde. Here the remaining part you need to get another aldehyde molecule. It is second position. Methyl is important. Then the option B is the correct answer. Here methyl is there. Simply cut, my dear students. Simply add oxygen for to balance the valency. Clear. The answer is option B. Next question, my dear students. It is from your chemical equilibrium. We already know. If it's just equilibrium, Kc value they are giving. Kc is equal to what? Kc is equal to O3 power 2 divided by O2 power cube. Here you need to calculate O3 power 2. I hope what is concentration of O2? Very simple. O2 you require now. O3 you require. O2 cube into Kc, you will get a O3 square, my dear bachcho. Kc value, what is the Kc value here? It is 3.0 into 10 power minus 59. Then O3 square value into O2 cube. Now O2 cube 0.04 whole power 2. Then O3 power 2. Solve it. You will get the answer as a 1.9 into 10 power minus 63. 1.9 into 10 power minus 63 you will get. Sorry, no, 4.32, not this one. Sorry guys, this is the answer, actual answer. Okay, you need to take a square root now, that's why. This is the answer. We are at the last question, my dear bachcho. The last question from your aldehyde ketone carboxylic acid concept. It is from your, what is the question? Which one of the following is not formed when acetone? Write on the acetone structure. By dear students, acetone structure. Acetone with a 2 pentanone. 1 2 3 1 2 3 4 5 2 pentanone. This is the answer. This is the one. In the presence of dilute NaOH, oh my god, dilute NaOH is nothing but what? Aldol. You can easily say, sir, aldol. 2 self 2 cross. Here if you get a self na, you will get this product, these two product, 2 self. Means CO here -2 you will get double bond S, this one and this one. The next thing is these two. Cross is thing is happening, but the option 2 is not possibility is there. Solve it. This is the today's homework question for you guys. Solve it. You will get the answer. Option 2 is the wrong answer. Students, this is about the entire 2022 analysis. I hope you cleared with all the concept what we discussed in the 2022, my dear bachcho. It is very important. I hope it is clear. Students, if you still not share the channel, then please share the channel for your friends and everyone. I am coming with an evening session with the 2021 paper, my dear bachcho. Students, you already know our slogan, right? Learn, grow and shine with the Tapasya. And they go, Namma Tapasya. Love you all. Love you so much, guys. I will meet you in soon in the next session. Love you. And they go, Namma Tapasya. Follow Tapasya, grow with Tapasya. Thank you so much. Bye.